Prof, are you back?
I'm back.
Thanks. You can start again, but we had one question. If we can answer the question, Prof. The question is, why do we have a 50-40-50 distribution if you should suggest that the last two levels or level 3 must make up 50% of the assessments?
That's, let me see. So is that in the chat window? Let's see if I can bring up the chat
Yes,
window.
it's in the chat.
Why do we have a 30-40-30 distribution if you suggest that the last two levels make up 30% of the assessment? Okay. Well, I guess that's in a sense that's well.
I'm sorry, Prof. Can I just say that you suggested that the last three levels, I was typing fast. I thought you wanted to answer before the break. So you suggested that the last two levels do not make up assessment, but yet it is part of our assessment. 30% of our assessment must make up the synthesis and the analysis.
Okay.
So my question is that. Thank you.
Okay, so so you could have 30% of your assessment, which is assignment based. It doesn't have to. That 30-40-30 is not a reference specifically just to the exam, is it? It's to the overall, a set of activities that students do to get their final grade. Now, if that's the case,
so it's just to our assessment, just exams, tests.
Just the exam, 30-40-30.
Yes.
Well, okay. Well, if that's what is specified, I would argue that it's too big, that synthesis and evaluation are too big, but clearly the people who are making these decisions have decided it will be that way. They may wish to debate what they mean by synthesis and evaluation. They may say that my definition is too sophisticated. So I suggest this is really a question for them. What sort of tasks do you have in mind for that 30%? That's the best answer I think I can give you.
No, thank you. That's good enough for me. That at least allows me to take it further. Thank you.
Yeah, that's a good question. Yeah. So nothing else at the moment?
I have a question. I haven't typed it, sorry.
Yeah, you have a question?
When we take our papers and we determine, we use Bloom's taxonomy to determine the levels and the percentages. In programming, it often happens that you ask the students to do a solution, and that solution is obviously falling in the higher levels of Bloom's taxonomy. But certain tasks within the solution falls on lower levels of Bloom's taxonomy. Do you include those marks with the higher level, or do you extract them and keep them at the lower level and take the entire solution and break that up for each mark?
Okay, you're a little garbled in the middle there. So there was something about a high level question, and then you said, but there's also something. Basically, can you summarize again that question?
I'll ask again.
Yeah, please.
Sometimes when you ask students to write a piece of code, and let's say it's a bigger solution, I don't know if you're going to address that later on in the seminar. If I have a last piece of code, some of that code will fall on the lower level of Bloom's taxonomy. Mm-hmm. Yet the question is a higher level Bloom's taxonomy. Mm. How do you deal with those? Do you extract certain marks from the question to say that this falls on the lower level and certain marks falls on the high level, or do you take the entire question in its entirety and say this is everything just high level?
Okay, I'm not sure that the original Bloom's taxonomy. Sorry.
Maybe I can. Sorry to interrupt, but maybe I can clarify. Say you take out the input statement and the output statement. You say that's level 1, but the rest is level 3 or 4, whatever the case may be. Is that possible?
Yeah, I think yes, you could say that certain aspects of the problem are a particular problem are at lower levels and assign points for those, and then yeah, I think I'm saying yes. Am I? In fact, I'd say in a sense that that's what you'll have to do with a 30, 40, 30 requirement.
But how do you deal with the scenario that if the student does not get the higher level thing going, they will never write that lower level code because it's dependent code. How do you deal with that scenario then? Because then it doesn't really matter that you say it's low level code; they will never get to it.
My concern with asking big questions, is that many students will read the question and say, "Well, I can't do all that," and then they won't do anything. So I worry a lot about giving big questions and then with the hope that I'll be able to give some marks for some parts of their answer, because some students just won't do it. So my instinct, this is not an instinct as a researcher, this is just a colleague who teaches. So it's just one opinion and not a privileged opinion. I tend to avoid asking, big questions like that, and then giving marks to the lower things. I tend to have separate questions for the lower things, for the fear that, and then you only get, if you've answered the lower questions and got them right, you don't get marks for then repeating the ability to answer those lower level questions on the big one. You get the marks in the bigger one for being.
Sorry, Raymond.
Yes.
Can you put that in context of not a 6-month programming course, but a 3-year curriculum? Should you not expect students to be able to produce something a bit more complex after 3 years?
Oh, absolutely. Absolutely. I mean, everything I say is in the context of that first semester, maybe even the first year, but I would prefer to stick to the first semester. As the degree goes on, of course, you expect much more from students. Bloom himself talked about how the taxonomy needs to be seen in the context of what students know. And in some sense, it's a spiral, so that as the student progresses, what might be a synthesis level activity early in their education, becomes a much lower level activity, a year or two later, and so on. You build up higher and higher. Am I making myself clear here? The very first time I ran into Bloom's taxonomy, it was at a research conference, and the keynote was being given by a fellow who designed programming languages for a living. And as far as he was concerned, the knowledge level in his perspective of the world, the knowledge level was just the capacity to write quite large programs. And then things like analysis and so on related to the ability to analyze programming languages. And then synthesis and evaluation was the ability to create and evaluate new programming languages. So I hope that anecdote explains what I'm getting at, which is, yes, you have to apply a context. So those of you in the third year of a degree, you expect much more from students. And my mapping that I've given you over the last few minutes does not apply to you. And I'd be hesitant to make a suggestion about what mapping you should use, because I don't have enough experience with teaching third-year students to really to suggest what it should be.
I think I can present a kind of a clarification in this regard. We've got 2 sets of participants here, some of them with particular focus on high school students that has started in a particular grade with some introductory programming in grade 10, moving onwards to grade 12, and then other contextualized participants that are part of a university setting that deals with first years moving onwards to third years. So the question was posed, particularly if I recognize the name, from somebody that's now involved within a school setting and looking at the school setting, still working with children, and then moving towards the end after doing a 3-year kind of an introductory to program.
Oh, I see.
Yes.
Yeah. Oh, I see.
In that context.
I have had something to do with with high schools education in Australia. I've worked on perhaps like you guys. We have if students study computing at the end of their high school, towards the end of high school, they can sit an exam that all students do in the state, in the entire state. And I've sat on the committee that writes that exam on several occasions. The difference is that it turns out that really a lot of the students can do very little by the end of that course at high school, very little indeed. And yeah, I mentioned when I started that at the high school level in Australia, we hand out a six level structure of grades, 1 to 6, where 6 is the best students and 1 is not very good at all. Students at the 5, 6 level in Australia tend to be very, very good programmers. A bit like that figure I showed earlier in the distribution of marks on the practical exam in one province in South Africa. And I'd expect those students to be able to do synthesis and evaluation questions, but not so much in an exam situation. I'd expect them to do it as, say, project work. Here in Australia, the mark the students get at the end of the software engineering course at high school level, there is an exam component to their grade, and there's also a project work component. So for the high grades, I'd expect them to hand in quite a good program. But the reality is, let me see if I can find it for you. This is something I actually meant to talk about. Am I still on screen share or not?
Yes.
Am I on screen share?
Yes, Prof.
You'll see part 3 right now, are you?
Yes, Prof.
Okay, let me open. Let's see if I can find it here. It's something I thought would come up talk 3, but it's relevant right now. It might come up again. Right. Back in 2013, it was one of the years that I sat on the committee to devise the high school certificate. So this is the end of high school exam that students do if they've studied a subject called software design and development. In Australia, they studied that for 2 years. And there was a question that had been asked many years earlier by a fellow called Roy. This means right now, but this was his question. He asked it, he gave this sort of code to the students. And then the question was, what are the values of length, breadth, and area after this code has been executed? And of course, you can see here that we've initialized length and breadth to 0, and then we've done the calculation, and only after the calculation have 5 and 4 been assigned to length and breadth. And yet, am I doing it? Yeah. Oh, when I wanted to put this question in the exam, the other members of the committee objected. They said, "Oh, this is too easy, Ray." And eventually, we arrived at the accommodation that we'd have it as the question 1, the first multiple choice question of the multiple choice component of the exam, of the 20 multiple choice questions, because we like to give them an easy multiple choice question to get them started. So my colleagues said in the exam. Now, that's the correct answer, I think. When the code finishes, length will have 5 in it, breadth will have 4, and area will have 0 because the calculation was done before the initialization. But I can tell you that these figures don't get released. So I can only do this because I was on the committee. About 30% of the students chose D. 30% of the students who'd studied this subject, software design and development, for 2 years at the end of high school chose that answer. So they don't know very much at the end of high school if they get that wrong. So I guess I've developed upon the question that the gentleman asked early on. Yes, I expect the students who do really well at high school to be able to write quite sophisticated pieces of code. I doubt that they should be required to do it under exam conditions, but I'd expect them to do it as project work. But an awful lot of other students, where was that graph I showed earlier for South Africa? Where is that? Here it is. is a quick answer. Is 7 the top level? Am I interpreting this the right way? And 1 is the bottom level?
Yes, Prof, you're correct.
Okay. Yeah. I mean, these students obviously are not being terribly pushed hard by the existing stuff. So I'd expect they should be able to write quite creatively and do some more work, more sophisticated than what they're currently doing. But you've got a lot of students down here who obviously can't cope with that sort of work. So have I answered your question or not?
Yeah, Prof, absolutely. Just to give you a bit of context, is those questions in our end of year grade 12 examinations are scaffolded. So in other words, it'll be write a class, but write this method with this parameters, or things like that. It's usually the last question which is left over to. But in grade 10, which is our introductory course, you're absolutely right about that, about those taxonomies, and it's you need to scaffold those questions properly in order to give students a good chance.
Part of I may have given a slightly wrong impression. I'm trying to fit examples of application analysis questions on single PowerPoint slides, so they tend to be quite small pieces of code. I think you can a page of code could be a difficult application question. But it nevertheless could be an application question in an exam. I wouldn't have many of them. I think you just indicated in your comments that that's like the final question on the paper. So that would be, that would be okay. When I talk about
Prof.
synthesis and evaluation, I'm talking about bigger things than that. Sorry.
Yeah, if you could contextualize that, because we have a 3-hour practical where they need to write code. So does the opportunity to be able to execute and test your code change it as opposed to a written answer in code?
Yeah. Did you say 3 hours? For the practical?
Yeah, 3 hours.
Okay. Wow. Yeah. Well, put it this way. I mean, yes is the short answer. I expect that could be synthesis and evaluation, 3-hour practical exam. You'd expect, the crucial thing to look for is, would you expect to see quite a lot of divergence in how the code works? You could look at 2 student solutions and say these are quite different, but they both do answer the question. Then that would be synthesis level. What I'm talking about more is a written exam. When I say shouldn't be in an exam, I mean a written exam, and I mean an exam that's trying to cover all the levels.
Thank you, Prof.
Yeah, is that making sense? So
yeah. No, absolutely.
Disregard my question somewhat if it's a special exam where they're given a large piece of code to write for over a 3-hour period. Yes, you could ask a synthesis level question in that environment.
Great.
I would worry. If that's what you do and that's what's mandated, fine, do it. As a teacher, again, not a privileged research-based position, but I worry about the weaker students. Remember what happened in the McCracken case? Here we are. The students were given quite a difficult thing to do. By the way, I won't tell you what it did because it's quite a difficult task, and a lot of those students have just bombed out. And I suspect that a lot of these students down here just gave up. That's what worries me about long practical-based exams. It's the students who give up. But I suppose the answer in a high school environment is that you tell the students don't give up, just keep going and put something down. You will get points for trying.
Yeah, Prof. I think that's absolutely. I'd be interested for you to have a look at one of these practical exams there. For instance, I know the database question is typically like 10 different queries, of which you can kind of get some wrong and they start off easier and things like that. So it's not just one task. It's broken out, scaffolded. There's 2 marks for this method, perhaps, or a mark for this for loop, or a mark for reading in from a file, or 10 marks, or whatever the case would be. So I'd be interested for you to have a look at a selection of those.
I think I can do that. If you want to contact me, or we can. Perhaps the organisers can settle on a particular exam that is appropriate to most of you, and we could talk a little bit about that.
Yeah.
I think the organisers may have sent me that a week or 2 or 3 ago. It might be useful if they send me that again if they've got that one in mind, just so that I've got the right thing. Yes, it might be helpful if I see an actual exam that you guys are using. I'm sorry, but those comments about synthesis and evaluation being too hard really does. It's the context in which I've given exams, which is paper-based, and where you're looking you're looking for a good mix of questions. So a good percentage of the exam has to be at the lower levels, and that just squeezes out space for large open-ended questions at the end. Anything else?
No, thank you, Prof. I've taken enough of your time. Thank you.
Now, before we go any further, we're getting the end of what was going to be my 2-hour period, and I haven't started part 3, and maybe I don't see a lot of point to doing that today. Maybe we've done enough. What do the organisers think?
Professor Lesser, thank you very much. We will just give us a minute to deliberate on it, but I would like to clarify something, and that is wonderful. In South Africa, we've got, if it comes to the schooling system, as you have in Australia, the different provinces, if I can call it provinces or districts, like New South Wales, Victoria, and so forth, we've got 3 assessment bodies for our high school learners that provides assessment opportunities and then ultimately the certification. There is the Department of Basic Education that Karina is involved with, that you know. Then we have what's called the Independent Examinations Board, and we've got another organization called Sakai. And if I'm not mistaken, Mr. Dominic is from the Independent Examinations Board, and they also follow an approach. We did share some exams.
Sorry, Bertie. I just need to correct you there. I'm online as part of my school. I have no connection with the IEB in an official capacity at all.
Really? Sorry.
It's fine. I have examined for both before, though. Yes, thanks.
Oh, sorry.
No, it's fine, Bertie. I just needed to clarify that. Okay. I'm not in any way officially connected there.
Okay. So we've got 3 examination boards, and they all set different exams. From the DBE side, we did send you one of our grade 12 papers to have a look at. And Dominic, sorry then for interrupting. Will it be possible for you to find us maybe an IEB exam? I know you're not involved, but you indicated.
No, they are freely available on the IEB website. I'm sure I could send a link.
Okay, so that's fine. Yeah. And maybe send one to the prof as well during the week. We weren't expecting to look at it today, but maybe or something like that.
No, thank you, Bertie. Yeah, no, absolutely, and thank you for all the work you've done on this as well. I know you've been involved for years.
Thanks, Prof. Joey, what do you think? Do you think we can go more on questions and answers? Our next session, I don't have the program open. Oh, I do have the program open in front of me. Is at 12:15. Professor Lester was scheduled to work on. I think. Prof. Lester, if you don't mind, maybe go on a little bit with this talk, and if we don't finish, then we can, if it's okay with you, we can continue tomorrow, as there is some time left.
Sure.
Okay. I also, can I just, sorry, Bertie, you came in before I could. Prof, I especially would like that we go on with that, because we talked so much about Bloom this morning. If we go on now with how you applied Bloom, it will emphasize and make everything that you said stronger for us.
Okay. Let's see then. Let's see what. So did you say the next session starts at 12:15?
That's correct.
We have
probably a little bit of a break before that 12:15 session starts. Is that
right? The break is at 12 o'clock, and then there's a 15-minute tea time or something before the next speaker.
Okay. Well, let's see what we can do in this, at least in this next 5 minutes. I might abbreviate some of this stuff.
Sorry, Raymond. We only 11 o'clock here with us, so it's an hour till 12 o'clock.
Oh, okay. So I can take my time at this portion of it then. Okay. Well, anyway, put it this way: if I'm talking too long, you will stop me.
No, I promise you,
are
Prof,
welcome to
the people are hanging to your lips. Thanks.
So, where are we? Am I still sharing my screen? Do you see part 3 right now?
Yes.
That is correct.
Good. So this is how I applied Bloom, and I just want to make a note that this is how I was applying it back in around 2002 to 2004. I will talk again later, probably in the third talk, about how it had been modified, towards the end of my teaching again. But I think it's important to see how it was done then and the reasons why I changed. I just want to remind you, we've got these 3 groups of students, so you can give them other names if you wish, and I've given them these flippant names, Picasso's, watercolorists, and figure painters. And so what I was trying to do was, again, so we had the simple, the non-trivial, but very structured and larger and creative. And then what I wanted to do is, have each of these types of students work in those sort of areas. Okay, so to get the highest, we have a little problem. Well, it's not a problem, but let me ambiguate that. In Australia, we have pass, credit, distinction, high distinction. We have 4 passing grades. And I think if I remember a conversation we had as we were planning these talks, you have 2 passing grades in the university system. Is that right? Did I get that right? Somebody? Karina? Is there 2 passing grades at the university level?
Yes, Prof. Yes.
Okay. So we would have to, I may talk in terms of my 5 levels, but the students who got the highest possible grade at my university, I had them doing evaluation and synthesis type tasks. The students who got a bare pass, the bottom pass, were doing tasks down at mostly at the comprehension level, and the students who got one of the middle 2 grades were doing tasks in that middle level. So I'm going to work from the top down to get one of to get the highest grade. And a rule of thumb is 10 to 15% of the students should get the highest grade. They have to do everything that the other guys do, but being very talented, it doesn't take them very long to do those very knowledgeable. It doesn't take them long to do that, so that's not onerous. They have to do everything else, but then I gave them, write a program. You decide what it does. I gave them a little bit more than that. For example, I would say to them, it must have a certain number of lines of code. From memory, I think I only specified 200 lines, but many students wrote more than that. And what would happen is that the students would write their program, and then I would get them to swap their programs around, and they would peer evaluate each other's programs by the sort of criteria for a good program that I gave to them. So that's what they had to do for the highest possible grade. That's not done under exam conditions. This is a project they do during the semester. Now, for the watercolorists, the middle 2 passing grades, they had to do everything that these lower guys did. They didn't have to do what the Picassos did. They had to do what these guys do, and then they did this stuff. They had to do basically an assignment, and I won't say much about it. They added small bits of code to. My style of assignment is usually not a blank page or a blank screen where they start from scratch. I usually give them code and then I start asking them to add bits of code to do this, that, and the other thing inside them. Not a lot to say there. I might say something about if there's, it's a very typical kind of an assignment that is often used, at least in Australia. If not, I don't know what would be typical for an assignment where you are, but nothing surprising so far there for the middle level. The things that were really different were in the lower levels. I gave out passing grades effectively to students who could demonstrate to me a comprehension level capacity. There were 2 components to it. One was a lab practical exam, and all they had to do in the practical exam was convert some given pseudocode to code, and it had to work. Now, this is the thing. It had to work. It wasn't like, well, you almost got your program working, I'm going to give you a pass. No, you had to make it work. I think that one of the things we often do when we're teaching introductory programming is we hand out passing grades to things that kind of work but don't really. And the biggest lesson we teach the students is that, getting something to work half right is good enough, which of course is never the case in software engineering. Things have got to work much better than that if they're going to be useful. So that was why I was very insistent that they had to make their pseudocode work. That sounds drastic, but I wasn't giving them only one attempt. They could have multiple attempts. to get that right. Usually what I would do is students would have a second attempt, and then a small number would need a third attempt. And there were some students who would fail at this point, still couldn't get their pseudocode to work after their third attempt. And what I'd say to them is, well, at the end of semester, you've got to do an exam anyway. If you pass that exam, I'll allow you to do this practical exam again. I don't think a student who needed more than 3 attempts, who failed after 3 attempts on the practical exam, ever passed the multiple choice. I don't think I ever had to fulfill that offer. So that's the practical exam. Very modest. They just have to make the pseudo. It's effectively making sure that they can, they know syntax effectively. That's all. Now on the next slide, I'm going to talk about the multiple choice exam.
Raymond, was the pseudocode marked by hand?
In those days, yes.
Okay. You don't have anything that can run?
We're talking about 2002, 2003, 2004.
You don't have a tool that can run pseudocode, can you? Do you?
We certainly didn't have anything like that in those days.
Okay.
I used to. It wasn't hard for us to. I mean, you basically, a tutor would walk around. It would take them seconds to see if the program was working. So I just had them, a little sheet, and I used to tick off names if they saw it working. You could go down that route, definitely could go down that route of an automatic submission system. In fact, by the time I finished teaching in 2020, we were using an automatic submission system. But back then it was manual. End of semester, it wasn't onerous on the tutors because you just had to say whether it worked or not, and you just had to give a tick, and that was it. So there was an end of semester final exam. Just to remind you that there was a lab prac, I've left that one line up there. And then I'm going to tell you about the exam. Multiple choice, code tracing tasks, and select the missing line tasks. So those two types of tasks, that's all there was. It wasn't a 50% pass. I used a 70% pass. Again, if you didn't pass it the first time, you could have 2 more attempts. The fact that this exam was at the end of semester was a problem because you remember I was saying, in order to get, say, the Picassos up here, in order to get their grade, they had to do everything up here and then do this stuff here. So they had to do their projects during semester under the assumption that they then would pass the exam. Now they did. Students who could work at this level always passed the exam. That wasn't difficult, but it caused a lot of apprehension that they didn't know for sure until the end. So that was a problem. More with the students' attitude than with the effectiveness of the learning. Now, so that's what code tracing, select the missing line, 70% pass, multiple attempts, end of semester problem. Okay, and now this is the bit that you're not going to like. For the missing line questions, we initially used a mix of seen and unseen code. That intuitively makes sense, right? Some of the pieces of code that we present them with was seen code, meaning they'd seen them in lectures and in lab work earlier in the semester, and they had to provide missing lines of code for those. Some of them were also unseen pieces of code where they'd never seen it before, and we'd ask them to provide the missing line. And that seems intuitively clear that you need that because you're worried about rote learning and so on on the seen ones. You want to see that they can do some unseen ones. We actually dropped that later. The first few semesters we did it this way, but we dropped it because it takes a lot of work every semester to write the new questions. And it just turned out it wasn't necessary. We dropped the unseen questions because, let me show you these statistics. On the missing line questions with the previously seen code, so they've seen the questions in lectures or in lab work earlier in semester, on this code they'd already seen, the students with the bare passing grade, the finger painters as I keep calling them, were scoring between 63 and 89% on those questions. 63 to 89% of them getting them right. And just to clarify that a little bit more, the median was 81%. So 81% of the class on average, as a median score, were getting each of the previously seen questions right. And then we discovered on the unseen code, the code they'd never seen before, 63 to 85% of them were getting it right. So almost the same percentage. Just to underline that further, the median figure, 78%, is almost the same. So we started saying to ourselves, why are we beating ourselves up writing all these new questions every semester when it's pretty clear that it's not adding anything to the exam? to have unseen questions, we might as well just stay with the previously seen ones. And that's what we did. But again, I'll remind you, so we dropped the unseen code from the exam, but we gave them lots and lots of seen code. We gave them lots and lots of examples to learn from. And, you know, we may disagree on how many pieces of code they need to see, but certainly everyone can satisfy themselves that at some point, if you give them enough code, effectively all the code is unseen because they just can't possibly learn it or so on. Okay, so let me back up just for a second on that. So we had this mixing of tracing and missing lines, and now as time went on, we dropped the unseen code and just stayed with a great big pool. In fact, by the time we finished this, we had a great big pool of multiple choice questions, and we just used to release the entire pool to the students and say a percentage of these questions will be in the exam, and then just left them to it to work on those questions. Controversial. A lot of you aren't going to like that, I know. How did it work out? Well, firstly, our failure rates are typically, before this, we started on this system, were between 30 and 40%, which was considered too high. And so we needed to improve on that. Now, after the students had done the first multiple choice exam, there was still 29% of them failing, which is not good. But remember, I said they had multiple attempts. So after the third attempt, the failure rate was down to 10%. So some students needed the kick the kick of failing the first attempt to really get their act together and study seriously by the time they get to the third one. Different exam each time. The first exam, the second, third, and the third multiple choice exam, they weren't exactly the same exam. They were different exams each time. And the rule was that, you know, if you were going to score a higher grade, you had to pass the first multiple choice exam. So that's why there's dashes over here. But the 29% failure rate went down to 10, and that meant, of course, our bare passing grade went up to 37%. So we were happy with that. We were starting to see the sort of passing rates that the university wanted to see. That was a good year. They vary mostly between 10 and 15, and sometimes almost 20% fail even later. Now, here's the question. I think that you're worried that if I'm going to do that, multiple choice exam, with nothing but tracing questions and missing lines of code, am I asking too little of that first passing grade? I mean, are they going to be what's called streamed? I don't know if that's a term used these days in South Africa, but it was a common term in years past. What it means to be streamed is that and this used to be a thing they did a lot in high school, so that you would be relegated to one of the lower level classes for, you know, factory fodder, to put it crudely. And it would be impossible for you, once you're in one of those lower level classes, to then in high school to rise back up into one of the more academically gifted classes. And of course, that's not a very good thing. And so even though there wasn't multiple classes, were we effectively streaming the students by allowing them to pass when all they could do were the tracing questions and the missing lines of code? And no is the answer, because we tracked some of the students through to their third semester, and we found that if you'd got a bare pass in that first semester, it didn't necessarily stop you from getting a higher grade later on. 32% of them, a third of them still got a bare pass, but 2/3 of them, almost, getting up towards 2/3 of them, got a higher grade in that third semester. So we hadn't streamed them. In fact, what we were doing the opposite. Because we were insisting that they knew the basics well, they were able to build upon that foundation of the basics and learn the material for themselves. Whereas in a more traditional environment, because they knew nothing really coming out of the first semester, they were streamed because they just didn't know enough. How do the students feel about this sort of stuff? My learning experiences in this subject were interesting and thought-provoking. This is a standard class survey question we have in our university. 69% of them agreed. And I don't know what it's like in South Africa, but let me tell you, a first programming subject in a university with a 69% of students agreeing that their experiences using Port-Pirie, that is unusual in Australia. And it comes about because each type of student, the Picassos, the watercolorists, the finger painters, are being given learning activities and assessment activities that are consistent with their level of ability. So that's why you get 69% of students agreeing that that's good. I found the assessment fair and reasonable. Well, the good news is that almost 2 out of 3 students agree with that as well. High neutral, and that was because the multiple choice exam was at the end of the semester, so these students have to do the survey before they do the multiple choice exam. That's just the way the university worked. And so a lot of them said, well, I'm reserving judgment on that until I've done the multiple choice exam, which is fair enough. So that's why it's high neutral. But even with that, 64% saying that they like the assessment in a first year programming subject at university in Australia is rare. Anything else? No, I think this is just a summary. And then yeah, that's just a summary. That just summarizes the system. Yeah, well, that seems to be under revision because I'm assuming what I'm saying there is how we do things, how we did it with a written exam, and students had to sit. Everybody had to sit the written exam, and I've been insisting that evaluation and synthesis can't be done. But I think I'm overgeneralizing. As you were explaining earlier, if you've got a 3-hour practical exam, then you can ask synthesis and evaluation level questions in that sort. What would I be advocating in South Africa? Well, obviously I'm working from a position of profound ignorance. So just take this as a suggestion and feel free to say that, well, that's a starting point, but you're wrong. Probably you're looking at knowledge and comprehension, the lower 2 levels for these are the sort of questions you'd expect these sort of students to be able to answer. I'm not sure about this 3rd level. That's why when I put my next rectangle in, that these overlap. Maybe this 3rd level should be attempting application analysis. I don't know. I'd be giving those sort of questions to determine these sort of levels. And then, of course, we'd really like to test these students at the top by giving them synthesis and evaluation exercises. Sounds like with your practical exam, you're able to do that. Anything else? No, that's the end. That's it. That was a bit. Oh, but hang on. If I've got a little bit of time, do I have a little bit of time?
Yes, Prof, you do.
Let me show you this. I mean, I was very vague about what the actual activities were. So let me see if I can. So the middle students, remember, we're doing. When I say B, this is a slide I must have made for Americans because Americans relate to A, B, and C as 3 passing grades. So this is the middle passing grade. Is what I'm talking about. This is what we call Pig World. It was an environment we built. And then the assignment involved the students running Pig World or adding code to Pig World. Pig World is a world where the pigs run around. These little pigs run around, not doing very much at all except eating pig food, and that's pig food. There, I grant you, it doesn't look like pig food very much. It looks more like what comes out the other end of a pig. But there you go. We didn't have an art budget, so they add stuff to that, and what For amusement value, let me show you this. One of the things in Pig World is that after they'd eaten enough food, pigs moved into a different mode where they were what we called in the mood for love. And so a boy pig and a girl pig would find each other, and if they're in the mood for love, they created a baby pig, which I'd have to tell you worked a treat in the university environment. The students loved it. When I showed them this in the lecture where I introduced the assignment, you invariably got applause. The fact that there was sex and new objects and so on. I don't know whether it's appropriate for the high school environment, but it worked a treat in the university environment. A lot of classes, but that was more. The students were told, I want you to go into a certain class and I want you to add some code, which does a very specific thing to a very specific method. So although there was a lot of code given to them, it was the assignment was very targeted. Add a bit of code here, add a bit of code there. One of the reasons for giving so much code was because we wanted the Picassos to be exposed to a lot of code so they could just see what was going on. Yeah. So the assignment tasks were things like enhancing pig behaviours, new pigs. Now, part of the reason for showing you Pig World is because I wanted to show you what my Picassos could do, what the highest grade students would do. This is one of the, remember I said, write a program, you decide what it does. And this is the program that one of the students wrote. It's one of those games where, you hit this, if this was the real program running, I'd hit the scramble button. Well, in fact, I think I've got a PowerPoint that does that. Yeah. You hit the scramble button and the picture is scrambled. And then by using these buttons, selecting a square and hitting up, down, and so on, you move everything around until it's you've got the picture back again. And the thing that I love about this, and I'm so proud to show it to other people, is actually the student built it on top of Pig World. These squares are actually like little animals, non-pigs, inside a Pig World. I'd spent quite a bit of time just rambling in lectures about how we liked Java and object-oriented programming because what we could do is we could extend the code. And I kind of used to say those things in the class, but I never really expected students to listen to it very much. But in fact, what one of these high-achieving students did was he did listen to me, or she, I can't remember, or she. And the student extended Pigworld to do this. And I was just blown away when that student handed that piece of work in. Another student did the same thing. They caught onto that idea after that, and a lot of students did it. This is, that card game that you might play with a child, where you lay cards face down on the ground, and you turn a card over, and then you've got to turn a second card over, and the aim is to match up the pictures as they do there, for example. Well, that one student just did that by clicking on pictures on squares, and again, this was built upon Pigworld. Just marvelous stuff. I have done something like this in a database course. For the evaluation synthesis levels, the students built a database of their own choice. They used to have to do things like come to class and present it and talk to me about it and so on. To do this one, when I say 7, don't worry about these. This is a reference to grades, and this is the Queensland system where students get 7 different grades. But anyway, for a lower level one, I asked the students to peer review a project that a student had written at this level, and that might seem to be breaking the rules about how could they analyse a code that's written up here. But in fact, the thing with databases is I could ask a student to look at an ERD, an entity relationship diagram, rather than the whole database, and just say whether they think it's right, whether it was built right. That was practical. And they had to build they did a standard assignment where they built a given database. And the students who were getting a bare pass, the finger painters in the database class, had multiple lab tests and lab exercises where they mostly wrote SQL queries, some of them quite sophisticated queries. So they were demonstrating to me that they'd learnt something about databases. They would walk into the lab and they'd be given an ERD which described a database, and then they were asked to write a series of queries for that database. So they were demonstrating some capacity to use the database. The students in the middle layers were demonstrating an ability to build a very well-defined database and to evaluate an ERD. And these guys were just given a chance to knock themselves out and build something of their own interest. No, I don't think I'll worry about that. What on earth is this doing here? This was one of the database assignments I had the students work on. I don't think it's that important, but once again, with undergraduates, building a dating site, this is pre-Tinder days, building a dating site I thought had some appeal to university students. I used to construct web pages where I'd have what I called the Hall of Fame of projects that have been done by earlier students. And so when students had to critique an ERD or something like that, they could choose from the various projects done by early students in an earlier semester. Students were pretty happy with this in the database course. My learning experience in the subject were interesting and thought-provoking. Strongly agree and agree. I mean, almost, basically 90% of students agreed. The learning experience was interesting and thought-provoking. The assessment was fair and reasonable. Again, very strong agreement with that. So again, because students were working at a level that was appropriate for them. And that's just a repeat, I think. And I think I'm out of slides. Let me just check. Yeah, I've got other slides, but they are about the kind of rejects. Yeah, so I think I'll wind it up at that point. So we're at 7:19. What did I misunderstand, Bertie and Carita? You wanted a 1-hour talk or a 2-hour talk out of me?
No. This is 100% fine. So what we can do, we can open the floor for maybe some direct questions. I'm going to share a MS form also to the participants later on, where they can provide us with some comment and feedback that we can discuss some tomorrow. I'll present a summary later on, and if you've got time, Prof, you can maybe read through it. I have a question, if that would be appropriate, and I don't think it's something that is out of scope. Let's say, for example, we take a practical question that is part of a practical paper, because in our high schools there's a theoretical and a practical paper, and the practical paper is done in a practical session where the students code. It's the same in our university, and my colleague Mr. Retief hinted towards that. Let's say we set a question, and they are going to write, as part of their programming paper, they are going to write 4 different programs, attesting different types of aspects as part of the curriculum and outcomes. Let's say we formulate a particular question, and we say, I'm just going to thumbsuck an example. Write a program that will allow a user to enter 3 different values in variables A, B, and C, and determine whether the variables are or the values that have been entered are sorted or not, display an appropriate message whether it's sorted or not. And then it's provided, and the question is bulleted in sub-questions. Write a piece of code, let's say it's question 1.1, write a piece of code that will allow or declare, let's make it easier, declare 3 suitable integer variables. Question 1.1. 1.2, write a piece of code that will allow the user to enter the 3 variables, values for the variables. 1.3, write a piece of code that will determine whether the values entered are in an ordered format. 1.4, display the results is in an ordered format or not. If we take that particular, we can say, and we want to kindly gauge your opinion on it, that question 1.1 and 1.2 are definitely on a lower level, and then question 1.3 is on a higher level if we need to do the analysis. What is your take on it? And let's say the question is presented in a bulleted format as opposed to a number format. How do you see the analysis, and what would you regard as a typical analysis for that?
Let's see. So the first part was the declaration of the variables. The second part was the reading in the values, and the final part, I'm skipping over one part. The final part was the outputting of the answer, I think, was it? Or
yes, they can say the one is the determination whether they are indeed in an order, and then the final one is to display whether yes they are or no they're not.
Yeah. So I think that most of those bullet point forms are comprehension. Because off the top of my head, it doesn't sound like there's much crucial information that's missing that's not supplied in the question. The one where your determination of whether they are in order, it's definitely at least application, yes, because you're not telling them how to do that, and they have to figure that out for themselves. And actually, students in their first semester of programming at university would struggle. Quite a few of them would struggle to do that.
Okay.
Does that answer your question, Bertie?
Yes.
So comprehension, application, comprehension, I think, is what I'm nominating.
Yes, no, we are totally in agreement in that regard. And the next thing that I would like you to comment on, if you can, let's say it's the way that the question is presented. If the question is presented in a structured format where there's sub-bullets or sub-numbering, like I've explained it now, for me, it's easier then to differentiate, like you've done, between the different cognitive levels, as opposed to just writing it as one big question, as a paragraph. What is your take on that?
Yes, it can go up the levels. The more information you leave out, the higher it will tend to go. Yeah. So if you just started that of just write a program that reads in 3 values and then outputs whether the 3 values are in order, and that's the whole question. Well, that's certainly at least application. It's the highest of the 3 of the bullet pointed form. It's at least that. I would argue for application by the criteria that I've given earlier, where I'm quoting out of Bloom's taxonomy. Perhaps I'm a little bit, let's leave it at that. I would call that an application level.
Thanks, Prof. No, you've answered the question perfectly, and I totally agree with what you are saying in that regard. Is there anybody else with a question that maybe would like to put on the mic, or if you're uncomfortable in putting it on the mic, you're more than welcome to place it on the chat room, Prof. Lister. There was another question from my colleague. Did you mention that you have had a tool to analyze pseudocode, or was it done by inspection of a student with the eye?
No. Oh, you're talking to me? Yes. No, we didn't have a tool that analysed pseudocode. No.
Okay.
We've never had that.
And then in
the early days that I'm talking about, 2002 to 2004, yeah, we actually manually marked the code that the students, we walked around that lab where you have to get the pseudocode translated into working code. We just had a tutor who'd walk around, look at the program, run it. It had to be run and then give a quick scan. And the program was usually so short that was all. It was just a few seconds, and the tutor would tick the roll to say the person had passed it. That's all it was required. Towards the end of our, and I'll talk about this probably in talk 3, towards the end of my time, we were using an automatic system which would, put test cases through programs, and that made life quite a bit easier.
Thanks, Prof. And I see we have a hand. Hannes?
Yes, Prof. It's just an opinion question. We at our university, we have an on-screen marker where you can make ticks on code, and then we have another tool where you can make use of rubrics. In your opinion, which is the better method to use for assessment with students when it comes to source code?
Well, I've not really used either, if I understand what you mean, by the two systems.
In terms of the on-screen marker, you can compare it to just manually marking with a red pen.
Oh, I see. Okay. Generally, I'm in favour of rubrics because I used to teach several hundred. I mean, I don't have a strong opinion on this. You're just asking me for an opinion, and I certainly don't claim to have be an authority on this. I used to teach, hundreds of students, and therefore I had a small army of tutors who would, when we were doing the manual marking, would have to mark. And to get uniformity of the process across all those tutors, I had to give a reasonably specific rubric. Those of you in high schools, I'd imagine, have to be using rubrics as well. At least in Australia, I can say that you tend to use rubrics because there's an accountability issue. You've got to be able to justify the grade that you give to students. In fact, that's the same in universities now. If a student queries a grade, you've got to be able to give a fairly specific answer as to why you gave them a particular mark. So rubrics, yeah.
Did you use multi-mark rubrics or rubrics that has got a 1-0 more digital kind of scenario?
We moved over to the automatic grading system a number of years ago, or 7 or 8 years ago, and I have trouble remembering what I was doing now 20 years ago. My guess is that I didn't want to give my tutors much leeway because it would lead to inconsistency in marking. So I could imagine that I would have liked to have gone 0s and 1s, but there might have been times when I'd give them like 0, 1, 2 or something like that as possible marks. So yeah, I used to break it down quite a lot. But it changes from environment to environment. I don't have a firm opinion on this. Accountability was the big issue for us, and consistency of marking. In a different environment, you may not want to do it that way.
Cool, thank you.
I suppose I just added, there's one other issue, isn't there, with university students: accountability and reliability. And the other one is, frankly, I mean, when I first took on teaching programming, you'd have a small army of students forming a line outside your office every time an assignment or something like that was handed back, and they would query the mark. And that was a big workload, often for not much to show for it, because the student would come in and just say, no, this is right. So what we wanted to do with a rubric was allow the students to satisfy themselves that they'd got an appropriate mark.
I think all of us over here Prof, are well familiar with the idea of a small army outside of your office. So that is a term that we can all definitely relate to. We had another question from a person that asks, the lady asked, "Dear Prof, can you maybe share later on, not now, when you've got time, look and see if you had some old examples of the rubrics that you used to evaluate some of the assessment, and then we can share it maybe at a later stage." And then also there's a nice question from the lady, "Dear Prof, is there any best practices that you can share to teaching novice programmers? Are you changing the and how do you address the female learners or the girl programmers, especially if you look at young females? Research has recognized that they are not taking computer science or IT studies that much. What advice can you give in getting them engaged and so forth as well?" That is if I understand the question correctly.
I'll take the last part, and then you might have to remind me, Bertie, of the earlier parts. To some extent, I'll have to admit to being a failure when it comes to, being strong in the gender area. I've never researched in that area, and beyond trying to use my sort of basic common sense about how things should be done and avoiding things that might sound sexist, I don't think I've been particularly good at encouraging female students. All I will say there is that I'll try to say in my defence that at UTS we had a higher percentage of students, female students, doing IT than is standard worldwide. We used to get about 1 in 3. 1 in 3 of our students was female, and that's far higher than America, where it's more like 20%, I think.
Oh, that's fantastic.
Yeah, and so in my defence, in my shame, I have to admit that I don't think I did much. But if I'm forced to give a defence at my trial, it will be that the university was doing pretty well already in that regard. Now, can you break it up? What was the first piece, Bertie?
The first question is if Prof can maybe share some examples of rubrics that you used as part of your marking, maybe tomorrow or the day thereafter.
I'll try. I've just made a note here that share old rubrics. Yep, I'll have a look.
And then some tips. That is a follow-up question. Some tips maybe for the best way to approach novice programmers in teaching. And
approach. Is there any sort of more specific about what the approach is, or
just tips and hints? Just tips on what can be done to look at, especially novice programmers. And
maybe teaching tips.
Yeah, teaching tips.
Okay. At this stage, this may change with the feedback. We shall see from you guys. I would welcome some feedback, by the way, on how things went today, because even if it's a little bit negative, it means that I might be able to improve things in the next in the next 2 talks if you feel I'm not quite on the mark. I might have more to say about tips in the third talk. It's hard to be specific there. I could walk you through, week after week. I mean, some tips. One of the things that worked very well for us in the last few years was we tended to have we moved to what's called, colloquially would be called a mastery way of learning, although technically ours was called a Keller plan. And what we mean by that is, you do a module of work, and then you do a test on it. And if you fail the test, that was not a problem. You just come back the following week and do an equivalent test again. And obviously we'd like to think that you reviewed the material again before you had a second attempt. And you could have N attempts. As long as you passed all, I think we broke it up into 22 from memory, 22 modules. As long as you passed all 22 modules by the end of the semester. It didn't matter when you did them. And this worked out really well. This was in conjunction with lectures which were all videoed if they were live and then made available, and so on. So if a student missed a lecture for whatever reason, or in fact failed a test and wanted to review it by watching their lecture again, they could. This was probably one of the biggest things that improved our failure rate in the last few years. And I do have a PowerPoint slide, but actually maybe I can do without that. The biggest discovery for me in that was how many students miss a week or two here and there during semester for good reasons. You know, they're sick. Flu season, I don't know what the flu season is in South Africa, but the peak flu season here in Australia is like August, September, which is, you know, right in the middle of second semester. And there are some students who can be ill for a non-trivial amount of that time and miss quite a bit of what they need to learn. And what I discovered in the last few years when we moved to this mastery-based approach with the multiple tests that you could repeat was that the students who missed classes for whatever reason, they had a chance to catch up. In a very traditional programming course, the course moves on relentlessly. The lectures move, you know, the next week's lecture builds upon this week's lecture. So if a student misses this week's, they walk into the next one and it's a bit hard to follow what's going on. People get left behind in those systems through no real fault of their own. I mean, being sick is no real fault of their own. Goofing off is a fault, but being sick is not a fault. So that would be one tip I would suggest is try to move to a system which is more flexible in that way. Lots of students benefit from a second or third chance. There's probably some that I plan to talk about in the third lecture. I suppose another thing one of the things, you know, I showed you some survey results where the students would strongly agreed, neutral, disagree, whatever. But of course we have open-ended responses. And one of the consistent responses I got from students was that I was clear and patient in my explanations. I think you can't underestimate just how much trouble the students have with learning some of this material, and you need to be patient. And you know, it's very easy for a lecturer, probably for a high school teacher as well, for that matter, once you're very familiar with the material, to sort of begin to overestimate how quickly the students will absorb it themselves. I used to flippantly say to people we should change the programming language every semester because it slowed the lecturers down. They had to learn it too, and they weren't always familiar with it. So being slow and clear and very precise in explanations. It sounds a bit cute, I suppose, to say that, but BG, most university lecturers are not slow and patient in their explanations. They charge ahead. They make it very visible often just how much they don't want to be there. It's hard because, you know, a lot of these things about teaching tips is, maybe I should look at some of my old papers and I might share some of those. I don't tend to write teaching tip papers though. What I tend to do is, and this will become very obvious in tomorrow's talk, I'm very big on analysing what students do in their assessment activities, particularly the exam, to reach conclusions about where the students are struggling and so on, and then making modifications to how I teach on the basis of that feedback from the exams. But I don't know if it's tips is another. I'm struggling a little bit, and I should probably stop soon because I'm probably just waffling. But one that does come to mind is never be shy about giving more and more examples. A lesson I learned over many years the hard way, or it was the hard way for the students, if not me, was, you know, academics fall into they'll articulate a general principle, then they'll give one example, and then they'll move on. Now, people who already know something relate to that. People who don't know something do not. Most human beings do not learn that way. Most people generalize slowly from a number of examples. I had one educational psychologist who told me your students will not learn anything unless they see at least 7 examples of it. And I said to him at the time, I've never given 7 examples of anything in a lecture. So, you know, let's say 4 statements. look at your lecture notes. How many examples do you give before you send them away to write their own code? Do you give them 7? Probably not. Most probably give 2 or 3. So lots and lots and lots of examples. And this is the power of what I was talking about earlier about the exams, which consisted only of the so-called scene code. You don't necessarily have to go through all the code, show it to them in lectures. You can just give them a pool of questions. And of course, as you know, there's not much that's more motivating than saying to students, some of these questions will be in your exam. They will go and learn it themselves then. So use more examples. I suppose the biggest one of all, and it's so ingrained in me, and it's such a meta theme of my talks that I kind of forget to say it, which is don't rush to having your students write their own code. Have them trace things, have them work on examples of code of other people's. Delay as long as you can, in a sense, the need for them to write their own code, because most students, when we ask them to write their own code, are not well equipped to do so. They effectively learn how a for loop works by writing a bad one and then attempting to debug it. And that becomes a very frustrating process, a very unproductive process for most of them. So give more examples and get students to trace code. I'll probably talk more about that in the 3rd lecture. That's probably enough. I think I've rambled on that enough. It's the trouble with teaching.
Sorry, Prof. Raymond, if you can just finish, because I think we must give the people just a break to have their lunch this afternoon, but you can talk still. But can we wrap up in 5 minutes?
Oh, okay. I can wrap up right now unless there's more questions.
I just want to make a short comment, Prof, and I think it really links on to what you said. Often, also from a lecturer side, as you learn more, and you said maybe change programming language every semester. As a lecturer becomes more comfortable with a new language or a new technology, he or she intrinsically learn newer concepts and become a master of it every semester. And then we tend to think about our students in that way as well, that our assessments must also follow up with our own development. And so slightly we are increasing sometimes the cognitive demand without taking into cognizance that it may be the first time that student is also exposed to the content and that is presented. And I think that was a wonderful comment that you made.
Thank you, Bertie. Just to elaborate on this slightly too, just remember that the feedback you get out of your class is usually from the better students. Yeah. The students who are struggling tend not to talk that much. So be careful about increasing the pace of the material because of the feedback you're getting from some students who seem to be absorbing it very quickly and quite capably. They're the ones that talk. The quiet ones need you to be more patient.
That's fantastic. So, Prof. Joey, I think we're going to then have a small break. Our next presenter is Prof. Greiling from Nelson Mandela University. And I would just like to kindly ask all our attendees, I made a very short questionnaire, a forms questionnaire, and I would like everybody after Prof. Greiling has talked just to complete it for us so that we can have a database of your email address. You don't need to supply your email address, but it's also a little bit of feedback that you can provide for us based on today's sessions. And then we will share it. Your name and your surname is optional, as well as your email address. So in that regard, we would like you, if at all, to complete it for us, and we will show that after the second speaker. On our program, we've got next on our program.
Bertie, I will do it when we start again. I think later people just break now, that they can have their lunch, and then we will start again on 12:15 when I will introduce the next speaker on the program as well.
Yeah. So we would like to, for now, say thanks to Prof. Lister.
Prof. Lister.
Yes, and I think we can all give him a clap, because for me it was very, very informative and I've learned quite a lot. And then we'll see one another back in the room at, let's say, 12:10, and then to be in time for Prof. Greiling. Thanks, Prof. Lister, we really appreciate.
You're welcome,
And-
Betty.
And the other thing is, Prof, we also look forward to hear you talking tomorrow morning again. I just want to remind all the attendees that we will start tomorrow morning at 9 o'clock with our proceedings. We're listening to you again. So thank you very much for today. We really appreciated all the effort you've put in to prepare for us, and that we can share get all your knowledge that you've given to us. Thank you very much. But you feel free, you can also sit in to listen to the next talks that is going to start now in approximately a half an hour. But thank you very much, everybody. Then we will break now, and we will continue at 12:15 with the next speaker for the webinar. I think it's time that you get something to eat, that you're nourished and ready for the next session. Hallo Prof John.
Hallo, ek het net 'n skrikkie gehad. Ons het 'n load shedding oorskakeling gehad en toe verloor ek wifi, maar ek is nou op my hotspot.
Ag nee, dis goed so. Ek is baie bly dat jy daarom kon inkom, want Bertie, because Bertie said you had some problems on your side.
Yeah, just give me a chance. I'm just going to close my door because I was running around trying to organize Wi-Fi. Just going to cut out the other noise.
Okay.
Give me 30 seconds.
Okay, thanks so much. Okay, bye-bye.
Okay. Is my audio clear enough?
Yes, your audio is very clear.
Okay.
We said to the people that we will start at 12:15 exactly.
Okay. Can I start sharing, Salang, or would you rather not do that yet?
Start with what, sorry, Prof?
Sharing my screen.
Yes, you can start with sharing your screen, although your face looks very good.
No, I don't like my face. Okay. Why? See, I've been away for 2 weeks now. Suddenly, I don't know how to share on my Teams. It's under the more,
Yes,
eh?
remember, it's that little arrow there, just on the left side.
Oh yes, yeah. I'm thinking Zoom now. Sorry. Okay, so I'm going to share window. And now I've got too many windows open. There's TUT presentation. Can you see it?
Not yet, but we're waiting. It might continue with a delay.
Okay.
There we are.
Okay, I cannot see yet. I think it's maybe a delay on my side, but I can see Prof. John.
Okay, so you can see Bertie. Oh, you know what I did just now? I didn't share the sound.
Okay, that's it. Now everything is now correct, Prof. John.
Yeah, I'm just going to stop sharing quickly because I didn't click the sound button. Then you won't see my 1 minute video. You won't be able to hear my 1 minute video, so I'm just going to go there quickly. Include computer sound. There it is. TUT presentation. Are we happy?
Yes, we can see.
Okay.
Yeah.
Okay, I'm ready when you're ready.
Okay, I see it's 12:15 exactly. Thank you very much, everybody. I hope you had a very nice lunch and that you feel better after the break, because we concentrated a lot this morning and we really enjoyed Prof. Lister's presentations this morning. It was so enlightening for all of us. It was really good. And I think I'm actually looking forward to tomorrow morning's presentations also from Prof. Raymond. We will have tomorrow, we will have more time for discussions, but we can ask a little bit more questions on this Bloom's taxonomy and how to do it for programming. So we will have discussion time tomorrow to do that. I've seen there were quite a lot of people that still wanted to ask more questions on the use of a Bloom's taxonomy, and we will then do that tomorrow when Prof. Lister is talking to us. Then we're very glad to welcome Prof. John Greyling from Nelson Mandela University. He's an associate professor and HOD in computer science at Nelson Mandela University in Gqeberha, South Africa. He is mainly involved in teaching and research related to programming. Since 2017, he has been coordinating the Unplug Coding project, mainly with the Tanks Coding app, introducing learners to coding without the use of a computer. The project has reached around 25,000 learners across South Africa and targeted disadvantaged schools without computer labs. In 2021, he has been coordinating online and physical coding offline workshops, reaching nearly 1,000 educations in South Africa. We want to welcome him, and we're very, very glad that we can learn from him. I've seen some of the Tanks program, and I must say I was very, very impressed. So thank you very much, Prof. John, and we're glad that you can tell us about your program.
Thank you very much. I've really been looking forward to this, because every presentation I make is kind of a new reflection on where we currently are. And I feel a bit humbled speaking after a researcher, because I'm not a researcher. I'm just going to tell you stories. But I think it has some value, our experience. Bertie, if you don't mind, I did change the title slightly. When Bertie and myself agreed on the title a month or two ago, we said at the dawn of the fourth industrial revolution, but if we're really fair with ourselves, the dawn has passed already. People are really talking about the dawn of the fifth industrial revolution, but that kind of just emphasizes the urgency of what we do. We're not at the start of the fourth industrial revolution. The rest of the world is finished with it, and we're still trying to catch up. So I thought I'd just remove the dawn, because that's not factually true. I want to start with this photo, and if I was in a classroom, I would have asked you how many of you recognize the photo at the top. It's of Richard Akoto from Ghana. I think about 4 or 5 years ago, he put this photo up on Facebook of him teaching Microsoft Word to his class on a blackboard. This photo went viral within days, and I can't remember how many thousands or tens of thousands of people shared it and looked at it. And literally within a week, he was starting to receiving laptops and PCs from all over the world. That's the photo at the bottom. And soon we had the photos on Facebook of him actually now teaching his learners on laptops. And I'm in communication with him. I guess he's not too good in English, so he answers in very short sentences. But I want to acknowledge this spirit in Africa, and I'm doing this because I don't want to say people are not doing this. And I've seen this all across South Africa as well. Individuals, schools, NGOs really doing their best to bring the fourth industrial revolution to their communities. And nothing that I'm going to say today takes away the effort that they put in. I just want to emphasize this. I found this article on computer education in Kenya, and I think anyone from probably the vast majority of countries in Africa and many, this is a generic problem. The lack of computers, dysfunctional laboratories. The photo on the right-hand side, I took at a school near Mthatha, where all the PCs were stacked on top of each other and we were doing our games in front. These PCs are clearly not functional anymore. Computers are expensive. So it's not a cheap device that you need in schools. And I don't need to remind any of us, I've just had that stressful 2 minutes now in my life, the lack of electricity and the concept of load shedding. But we think load shedding is bad. there's worse than load shedding. There's schools that for 2, 3, 4 days, for a week, for 2 weeks, does not have electricity. The lack of internet is probably even a bigger problem than electricity. The lack of qualified teachers, and once again, I'm not pointing fingers to our teachers, but our teachers have been trained in other subjects. And we have very few teachers in our country that have been trained in coding and programming. And then something that I never thought of until I read it in a research paper, and then I started noticing it. And it's not only true for teachers. It's true for anyone that has never before worked on a laptop or a PC. They can do much more complex things if you don't put them in front of the laptop for the first time. And they call it teacher intimidation, which is a real thing that we need to acknowledge. And then the issue of security. 2 years ago, a school here in Gqeberha, at gunpoint in the middle of the school day, 120 tablets were stolen from them. And I think we understand this issue, that as soon as you put expensive devices in a school or in the hand of a child walking to school or on a taxi or on a bus, you create a security risk. And Bertie will appreciate that we've just in a 6-day workshop, that the things that I'm saying here, I understand more than 6 days ago, are very emotionally loaded statements. And I acknowledge that, but I want to say that for me, these are realities that we cannot ignore when we think computer education in the whole of Africa. The harsh realities in Africa, statistics. Now, I'm going to admit that this article is 3-4 years old that says there's 16,000 schools in South Africa that do not have computer labs. Maybe there's 1,000 less than 4 years ago, but I don't think there's an order less. This is a real problem. Remember, we only have 25,000 schools in the country. And in Ghana, 5% of the secondary schools do not have computers. And then the one at the bottom is really, really shocking. Nearly 90% of the learners across our continent do not have access to computers. And now this is probably my most emotionally loaded slide of my whole presentation. And I'm saying, is this our best solution to reach our children, thinking about the digital divide? And up front, I want to say, I'm not saying this is the wrong solution. As Richard Akota did, and I acknowledge what he's done, anyone that can put labs in their schools and get their kids in labs, I want to give full credit. When I ask this question, I'm not saying, is this the wrong solution? I'm saying, is this the best solution to reach the majority of our children in our continent and in our country? And at this stage, things might change in the future. At this stage, I'm saying categorically no. This cannot be our best solution. Because if we see this as our best solution, we are saying that those kids that are not in labs, their problem is not solved. And we need to think about this and really reflect on this. So how do we get him across the digital divide? And I trust that Jimmy Shabangu is in with the conversation now. I had a long chat with him this morning on LinkedIn after I used this photo to kind of promote my talk today. And Jimmy responded, and we had a very constructive discussion in which he said, why do we always show the African child in this way? Can't we be more positive? And I will reflect about this, because what he's saying is something that we can't ignore. But what I see in this photo says nothing negative about the African child. I think it says something negative about the adult on our continent. And if I have to be blunt, about the governments on our continent. What I'm seeing here is learners that are curious, that want to learn, that want to cross the digital divide. And we might perceive this as negative, but we can't ignore the reality if we want to find solutions. I am saying it's definitely negative about the leadership and the adults on our continent. So the Tangible Africa project is an engagement partnership between our Department of Computing Sciences and the Lever Foundation, an NPO in the city, which I see as my rollout partner. I just don't have enough capacity as an HOD and a department to do the rollout. So Lever Foundation has been a very strategic rollout partner for the past 3 years, and I have to acknowledge that this cannot be done without them. We've now reached over 50,000 learners in direct workshop by our own facilitators. That's how I get to the 50,000. Our kits have been distributed to over 600 schools. So if we had to count in the schools and what they've done in their schools, in their classrooms, which I can't count, I want to say we've probably reached over 100,000 learners since 2017. But counting becomes actually a problem. I should stop counting. It was easy when only us did workshops, but it's now become impossible. Our name, Tangible Africa. Tangible obviously means you can touch the code. And the Tanks app, which I'll show just now, will show you that you can literally touch the puzzle pieces. But for us, Tangible is as a higher level concept. It makes something that is very abstract to most teachers and most learners in our schools, something that becomes concrete, something that they can grasp, something that they can understand. And because of that, I've taught now 1,500 teachers in short training workshops of 4 hours. Code has been demystified for them. I can literally see their eyes lighten up in the first hour. I'm not saying they now C# or Python programmers. I'm just saying the concept of coding, which causes fear and anxiety amongst teachers to start off, is taken away. And for me, this is, if I can only do that, we've succeeded, but hopefully we're doing slightly more. Just on our logos, we're very excited about our logos. They're all based on our actual puzzle pieces. So we use different logos, but they use the basic design of our puzzle pieces. So that's just a design, a brag, but I won't refer to that again. You can just see that they actually change as we carry on. So when this project, at the start, it was just Tanks. When me and my honor student in January 2017 came together in my office, these were literally our objectives. We said we want to introduce coding to learners without the need of computers, but we agreed that we'll use phones. So up till last year, I used the concept of unplugged coding until purists told me unplugged means no devices. So I now kind of play safe and I say offline coding. We said to each other, we need to be able to do this in schools that have no electricity on that day and definitely no internet. We said to ourselves, we don't want to need 3 weeks of training. We want to go into and do 4 hours of training, and the teacher must be empowered to do something. It had to be a low budget intervention because this was born not from only Byron Batterson's vision, but from students telling me, over the past 30 years, Prof, when are you coming to our townships? When you are coming to my rural school? The kids there don't know about programming. And these schools don't have the budgets. So we said our intervention has to be low budget, but we're also very serious that it's got no compromise on quality. We're not going to teach superficial things that doesn't make a meaning, doesn't make sense. And then the fun activities. And this I read 2 months ago. I don't know whether you've realized that in the past 15 to 20 years, how important stand-up comedy has become in our culture, in our world. Well, we've got probably our biggest export in Trevor Noah. And they say the reason for that is that all of us, adults and children, have been thrown with so much technology and information overload that the only way for us to survive is to have fun, is to have comedy in our lives. And they say that's literally the reason why stand-up comedy is now much more popular than 20 years ago. So for us in teaching coding at school, we are very hesitant of throwing the kids with just more stress. We'd rather make it fun. get them on our side regarding coding. And then in third year university, they can have the stress and an honors, which they need to have to become brilliant programmers. But let's not throw stress at them in primary school. And that was our view in 2017 already. So why should we teach coding and robotics in our primary schools? I want to focus on primary schools because our program mainly focuses on primary schools, although what we do is relevant up to grade 12, and even the parents of my students enjoy it. So why do we teach coding and robotics? And the first answer is not to produce software developers. And this is, again, probably a very loaded statement. Bertie will appreciate that I'm now very sensitive about making loaded statements. But let's say it's my opinion. It's my opinion that whether a child can code at the end of grade 7 and write fancy programs is not, for me, the purpose of coding and robotics. And I'm open for disagreement, and I think there's probably room for different views. But this is the way that we look at our project. There is a desperate shortage of software developers in South Africa, and if I start reading, across Africa. So for us, it's very important that the learner becomes aware of these careers, because in our discipline, I've also been involved in marketing for 30 years. Of our discipline to schools, we compete with the professions. We compete with engineering, with accounting, with law, with medical. And we're not a profession. We kind of have 300 different careers that we're trying to sell to kids. And it's much easier than to choose engineering. So for us, it's critically important that the learners in primary school become aware of this discipline, whatever you want to call. But then I want to repeat, no fear or anxiety added. This must be something that sounds enticing and nice to them at primary school. And then for us, this is the important one. When we teach coding and robotics at school, coding is one of the 21st century skills. It's not the only one. And I don't need to say this, we all know these skills. And in a sense, if I look at it as a programmer for primary school, teacher for primary schools, I'm saying that coding just becomes my tool, and robotics obviously, becomes my tool to teach the learners the other skills. And the emphasis must be on the other skills, not on the coding and the robotics. It must be a tool. Again, a loaded statement, and I'm open for people that think differently, and they are welcome, and they will also be correct. But that's the perspective at which we look at offline coding. And then need I say this, for the coding fraternity, software development fraternity, we need more matrics at the end of matric that pass with a good maths mark. And if I want to address the needs of our economy, some of the coding and robotics curriculum in the primary school must ultimately lead to this. I'm trying to find the statistics, but I'm kind of sure that at the end of every year, our schooling system is producing less matrics with good maths. And that is a much bigger problem than having grade 7s that can't code. Because we recruiting and competing with the other disciplines from a shrinking pool, while the need for software developers in our economy is exponentially, I want to say, increasing. And this is the real thing that keeps me awake at night as an academic. So our project and the South African schools, we do not see our project becoming a textbook or aligning with the curriculum, whatever the curriculum looks like. That's not our purpose. We just don't have, I don't have the capacity, my team doesn't have the capacity. It's not our vision to become a part and parcel of any coding and robotics curriculum at school. For that, we would need much more capacity. We just can't. We'll never write textbooks. We'll never convince DBE that it must be included as part of a curriculum. That's not our purpose. We see our role as introducing coding to teachers primarily at this stage and to learners, taking away the fear of coding. And then definitely enhancing computational thinking and problem-solving skills. That is our main drive, not coding. And I think we have a huge responsibility to take the fear and anxiety about coding away from teachers. And obviously, our focus is on the schools without computers. Although I'm finding a growing number of schools well-resourced that are also saying that this offline or unplugged way has definite value, even if we have the best resourced laboratories. And we see what we do rather roll out in coding clubs, like chess clubs, post-curricular, outside curricular activities. And that's where our focus is, and that's where we've had the most success in schools, is outside the curriculum, outside the school hour, a coding club like a rugby training session after school. And I'll get to that soon. So just to repeat, and I'm bringing this back the whole time. Keith Gibson told me this. He's a legendary IT teacher. It's probably a general saying, but I've heard it from Keith Gibson. You cannot translate from French into English if you cannot speak French. So a very important part of our project is introducing problem solving and computational thinking. Loose from coding, before you code, or parallel to coding, not as coding. Because we're saying if you can't solve problems, if you can't think computationally, to try and code just doesn't make sense. And if you teach kids how to code and it doesn't enhance problem solving and computational thinking, it also does not make sense. Again, a loaded statement, but this is our perspective and this is how we plan our project. And then when we talk to teachers, and I'm not going to go into this, all of you know about this, we try to make them aware of the online resources available for free. The IITPSA talent search with all their previous papers. It's all challenges that you don't need computers for, co.org. One of the teachers literally went on Pinterest. I wasn't aware of that, and got excellent examples from Pinterest. But then part of our project, I commissioned Keith Gibson because I have huge respect for his view on computational thinking. And he compiled 40 activities. A few were borrowed, but most of them are new, and he references the borrowed ones. 40 computational activities that kids can do in class or in coding clubs. And if anyone is interested, you just email me and I'll email it to you. We don't sell these things. It's important for us to get teachers to start doing these activities in class. One of my favorite photos of the past 2 years, I received it from Selby Makuna from Hazyview. He did extra maths classes, and then while the kids were waiting for the taxi, they said to him, Prof, sir, we want some of those exciting examples that you gave us. And he took one example from Keith's compendium, and these are the kids solving the problems on the pavement while waiting for the taxi. There is so much story behind this photo that I get goosebumps every time I see it. So for the foundation phase, what we try and introduce in foundation phase, first of all, I spend the first hour in saying to teachers, listen, if you want to introduce coding to your learners, spend a few weeks just getting them to play the very traditional games that are an example of coding or a list of instructions. And hopscotch throughout Africa is well known, and that's the first one people always think of until we start talking about what coding really is. Simon Says, Twister. And then it's very interesting as I travel through the provinces that people come up with indigenous games that are also a list of instructions. So the demystifying coding starts with step one, where you just say to people, listen, coding is a list of instructions that tells a computer what to do. When you write a recipe, it's a list of instructions that tells the chef what to do. And when you play certain games, you're applying a list of instructions. And this you could do for a whole term. Remember, we're in no rush. We don't need developers at grade 7. We need to kind of just open this world to them. And if I had more time, I could do more, talk about more. And then we've put together 10 lessons. We call it the BOATS lesson plans with printed resources, etc. I'm just going to quickly show you visuals of some of the lessons. What is coding? Where you get these posters and the kids respond to where they put the shoe, where they stand relevant to the chair. And we teach them coding as a list of instructions. So they're responding to the instructions. Sequencing, you give them a list of posters, and they've got to sequence these posters in an order to make tea. This is the shoe example taken in a very under-resourced school in Mthatha. Thinking like a computer. You give them some recycled objects, you give them categories, and they've got to ask the if question to categorize these recycled, and all of this is low cost. There's no high cost intervention. Types of instructions. We teach them, okay, we've shown you the posters that let you move around a chair, but now go and draw your own instructions on how to brush your teeth. And then when they've done that, you say, okay, you've written your first program. Left, right, forwards, and backwards. I think we all know the grid mat, where you move stuff and they can physically do it in class. Now, if I had 15 minutes, I would say to you, write an essay on the body language that you see here. And tell me, do you think there's some computational thinking happening here? I'm subjective, but I have to agree that there is some computational thinking happening there, just looking at the body language. Different views, spatial orientation, the grade 1 and art teachers tell me that know about coding that being able to understand different views is critical. And this one, the learners were asked to draw their bedroom from the top and from the side. Or you take the lunchbox and you say, draw your lunchbox from the top and from the side, or from different angles. Debugging. This photo was taken in a rural school in Tsomo, where the learner was given a very basic debugging activity. Playing against a partner. So our foundation phase links up with the BOATS app, where the learners can toggle commands and do the move forward, turn left commands on the app. And then they can play against each other, or they can participate in tournaments. I won't say much about this, but we've had tournaments with 700 learners playing all across the country. If any teachers are listening, our next one will be in September, the Heritage Month BOATS tournament. And we hope to have thousands of kids playing. So please let me know if you want to register so we can keep you updated. So the intermediate and senior phases. The TANKS app was developed by Byron Patterson, and I always acknowledge him because in my 30 years of being a lecturer, this was one of the best honest projects that I've seen. And I always say people have had to go out and pay a software company to develop TANKS. It will most probably cost me at least R500,000. So Byron is still very much part of the project and very aware of what's happening. So I keep on acknowledging him for the great work he did in 2017 and for the vision he had. When he walked into my office, it was his vision, and I just grabbed onto it. So the basic concept of coding of TANKS is you get a tank on a screen. Your cell phone screen has got to reach a destination. You've got tangible puzzle pieces that you pack out. You take a photo of them, and the code executes on the screen. So the only expensive device here is a cell phone, which most teachers have. So in this scenario, the tank needs to move backwards, turn left, and then move forward twice. So the learner packs out the code using the puzzle pieces, takes a photo of the code. When happy that it's the correct puzzle pieces that were recognized, you press yes, and your tank moves. Okay, so I'm just going to quickly go through some of the levels. If you look at this one, I'm going to go out of presentation mode so that we can play a bit here. The tank has to go forward, turn right, go forward 3 times, turn right and go forward the 4th time. But you only give the learners 3 move forwards. The teachers asked me to do this. So immediately at level 3, they've got to think out of the box. And the way you solve that is go to start, move forward, turn right, move forward twice, and then since you have used all your backwards, you turn the opposite direction and move backwards. And immediately the child has to think. And Some learners pick this up very quickly, others really need to think, and even teachers and adults. But there's some nice problem solving happening in this example. In this one, the way that we introduce loops, we say to the teacher and the learner, move forward, turn right, move forward, turn right, move forward. And they've got a little trick aspect in Tanks that says early termination. So
John,
yes.
I've got a sound problem. Can you just repeat a little bit what you said in the last 5 or 10 seconds, please?
Did you hear this slide? I'm a bit worried. Can people hear me?
Yes, we can. I think, John, Prof. John, if you want to, you can maybe just close your camera and we can save a bit of bandwidth.
Oh, sorry. I'll do that immediately. Okay, apologies for that. Okay, now I just need to get to my screen. Okay, so maybe I'll just repeat this one quickly. Is the sound better now?
Thank you.
Okay.
Very good.
So what we have here is that you've got to move forward, turn right, move forward 2 times, turn right and move forward the 4th time, but you only have 3 move forwards. So we force them at the end to, well, they've got to think it up, to turn the wrong way and move backwards. When we get to this one, I'll take out the R. We say to the kid, write down the commands that will take you to the star. And then they see this and we say to them, what would you like to add here to get a real pattern? And they say, okay, now if I add an R, I will get a nice pattern. And we've got this little trinket tanks that we call early termination. So when the tank reaches the star, it won't execute the rest of the code. So they have a pattern here, and so it's start, repeat. What do I repeat 3 times? Move forward, turn right. I'm going very quickly through this. This just happens normally by the 2nd hour of the training. But when you do it this way, the teachers understand loops and learners. I mainly work with teachers, but if teachers can understand it, I know they will know how to explain it to learners. Then we introduce the while loop. I'm not going to say much about that. It's simply, while my path is clear, keep on moving forward. And because of the early termination, when it reaches the star, it stops. And I've trained 1,500 teachers, and I can assure you the vast majority, once we've explained this to them, I say to them, if I look at this code, how many times does the tank move forward? And then you explain to them, you've got the repeat here. That repeats 3 times. What is
Sorry,
it?
I'm not sure if it's only my sound that's that bad. Can some other people just as well?
Is the sound bad now?
No, we are clear.
Yeah, I have no problem.
Okay, all right, it's clear now.
Okay. Yeah, no, I'm not changing anything on my side, so I don't really know what to do. But please shout if you can't hear me. So if you say to them, this body of the loop is repeated 3 times, and it's all visual code, within 10 minutes they can do this. And they start understanding nested loops. What I'm saying is, we're talking about a 4-hour training session. And it's not teachers that are fooling me. I can see, they say, and they understand it. So we've introduced the concept of nested constructs to them. The if statement, without me even explaining the if statement, I say to them, look at this, use your gut feeling, understanding the infinite, and say to me, which of these 2 challenges has this as a solution. So this thing simply says, repeatedly ask, if my path is blocked, I must turn. If my path is not blocked, I must move forward. If it's blocked, I must turn right. And then clearly this is the solution. And as soon as it gets blocked, you turn right. And in a very playful way, you introduce the decision-making if construct to a teacher. Remember, my principle is I'm not making them software developers. I'm using problem solving and introducing coding concepts. We also realized last year, Kelly Bush is a teacher at Hudson Park that works with me on the content that we can't just talk coding and algorithmics. We're not going to think design thinking, digital citizenship, computational thinking. So what Kelly has done, she's come up with storybooks for foundation phase and senior phases where the teacher can work through these stories. And as they work through these stories, they are introduced to design thinking and problem solving and computational thinking. She's a very experienced foundation phase teacher. So when she says something works, I know she's practiced with it for years and it will work. Quickly, just on the parts, components of computational thinking. In this problem, the learners have to work out that I must first shoot away the rubble and then I must move. That's decomposition. This one, they must pick up that they need to repeat something 5 times to get to the start, pattern recognition. And this one, they've got to see, but it's irrelevant. I don't need to shoot away the rubble, abstraction, and then obviously I write down my code. So we have different lesson plans, instructional videos. I kind of daily now am sending out WhatsApps to learners across the country that get stuck in the game, and I WhatsApp them a little 2-minute video and they can continue. So our emphasis has been on keep it simple. We have very few big documents, except for the lesson plans. The rest is basic, short 2-minute videos that I can literally WhatsApp to anyone without using a lot of data. Typical workshops, they always work in teams. The one is taken in our labs, the other one is in Kayamandi in Stellenbosch. Tournaments, I think Leanda is online, I think I heard her voice. This was a tournament we had at her school on 6 o'clock in the morning, literally 2 months before COVID, with 120 learners participating in a coding tournament. Coding clubs, as I said, critical for us. That's our main reach to schools. We see this as an extracurricular activity, and it takes on various different forms. On the right-hand side, you're seeing a coding club on Saturdays in Tsomo. On the left-hand side, you're seeing Kala, where the teacher put up the data projector with the videos over break, and the kids were playing. And when they were finished, he said, okay, now you go and teach the younger grades. And I had a WhatsApp from him last week. This is 3 years later, and they're still doing it. They're participating in our tournament in 2 weeks' time. This is Coding Club in Excelsior, under-resourced school in Gqeberha with no labs. They've been running a coding club for a year, 2 afternoons a week, with 40 to 60 kids participating. And I've asked this teacher now to write me, and she's busy this holidays, a compendium of all the activities that she's used over this year. We want to combine them into a booklet, which we'll also be distributing at no cost to whoever wants to start a coding club and you don't have a computer. The coding clubs has now led to the first time, 3 weeks ago, we had an inter-schools coding tournament with 5 of the, let's say some of the top schools, well-resourced schools in the city participating one afternoon. There were 130 kids from 5 schools. And do you notice the photo on the left says coding has become a spectator sport? I wish you could have experienced the vibe that afternoon. My team were so emotional that now and then they were all crying. To see kids coding, to see parents looking on, to hearing the cheering, the singing. Coding became something like a rugby match. And when I'm saying fun, this is what we want. We want the kids to think positively about coding. So train the teacher has been our main focus. And we've trained about 1,500 teachers in physical and virtual workshops. Both work equally well. We are now going into a project with 3 of the major teacher unions, which will conclude with, through master trainers, training hopefully around 20,000 teachers across South Africa in offline coding. But the feedback I get from teachers is what is important to me. Coding has been demystified. They leave the session without the fear and the anxiety that they had the first time they heard about coding and robotics. They know where to start. And many don't start, but it's not the training's fault. It's just the program is too full at school, etc., etc. But they know where to start. They feel empowered. And because they have a wonderful 4 hours of training, I always say to them, if you don't laugh today, go and see a psychologist. You have too many problems. So they really enjoy the session, and this inspires them to go and share the fun with their kids. The Tangible Africa, the Africa part of Tangible Africa says we see ourselves across Africa in the next 5 years. We just received funding from Henley Business School in London to start a project in Rwanda, and we're busy negotiating the logistics of this. Bringing back to the skills, and we still say that we want to introduce learners to all of these skills, and we're probably subjective, but I think we are succeeding in the group work and all the other things that we are doing. Now, before I go to the next slide, my wife's grandmother once came back from church and she said, it was a brilliant sermon. There were 3 places where the pastor could have stopped. Now, this is the first place where I could have stopped, but I'm going to carry on. If you look at these 2 photos and you think about the 21st century skills, definitely there are skills being enhanced and carried over on the left-hand side. Loaded statement, I'm qualifying. But I do think that more skills are being taught on the right-hand side. If I could enhance this photo and focus on different groups in this photo, you'll see communication, you see collaboration, you will see strategy happening here in that photo, which I struggle to see when kids are sitting in front of a lab, in front of a screen. On the 18th of July, we're having our Coding for Mandela coding tournaments. It started off with 1 tournament in Gqeberha in March, and my team said to me, let's do it on Mandela Day. It has now kind of exploded in our face. I think we're looking at 47 sites across the country with, if it happens, over 5,000 learners participating. What is happening because of this tournament beforehand? And this was I chat to someone now, and we never expected this. People are preparing for this tournament like anything through the holidays. This is a WhatsApp I got yesterday from a teacher who's now challenged these learners to come to school so that they can prepare for the Mandela Day tournament. This is a guy I still wanted to ask him or her from where they are. Didn't ask. It's a WhatsApp I got while at the airport yesterday. This is the infamous level 34, very complicated. This is me drawing on the screen on my cell phone and answering him. And then he's saying, wow, now I understand. And I'm seeing, and just in the solution and the way we tackle it, I'm seeing decomposition, I'm seeing pattern matching and algorithm. I struggle to say abstraction, but the clever guys can probably. And this is a WhatsApp conversation between me and a learner. I don't even know his name, I don't know his gender, and I don't know where in the country. Then our last component of our project is we call it Impact Tomorrow. We don't have the resources yet to do this on a great scale because we've reached 50,000 learners, but we are trying our best to, when we identify talent, to say, how do we nurture this talent towards a degree in computer science? The guy in the middle there, Tulumanku, we call him our Tulumanku story. He played tanks in grade 6 in a school without any computers. He was one of those kids that no teacher ever noticed. He became very well at it with a lot of perseverance. I don't have time on that. He ended up becoming 7th in our national tournament at the end of grade 7. We lost contact with him, our fault. In the middle of grade 8, he WhatsApped me one day and said, Prof, I'm in a dysfunctional school. I'm going to go nowhere. So we got a sponsorship and we convinced a school, Alexander Road, to taking him, although they were full. He's now a grade 11 learner, doing brilliantly in IT. And the other day he spoke to my team and he said his vision is to do a PhD in computer science. The boy on the right-hand side is from a primary school here in the city, very under-resourced. My team kept on talking about Norman, this bright little guy, very enthusiastic. The vice president of Amazon a month ago gave him a scholarship to go and study at Alexander Road after primary school. And there's 2 others that we identified that the same person gave a scholarship to, David Brown, from his private capacity. This is the start of our little academy here in the city. Kids that complete all 35 levels are then given a 4-week online C# course. They use the videos I made during COVID for my students. When they've completed that course, we bring them into a group that meets on Saturdays, and they're going to get extra maths tutoring and also some coding. But physical process before they reach here. This is our first 10. This is informal. The teacher, the facilitator there, Lusanda, identified 4 or 5 kids in the mountains that really show talent in coding and computational thinking, but also looking at their schooling marks. So the guy standing up there is a engineer in town, which came to and got to know about what she does, and he's now volunteered. We don't pay him. Every Saturday, he gives them extra maths and coding, maths and English tutoring, and Lusanda gives them some coding. The only expense for them is for Lusanda to get them on a taxi from the mountains into the town. And I checked yesterday, they're still coming every Saturday. On the left-hand side is the concept of a coding club. Another WhatsApp I received yesterday, Saturday maybe. They've started their own coding club in Ventersdorp. And after we sent them some coding games. The photo on the right-hand side I received yesterday at the airport at Oliver Tambo. A young guy from Katlehong. I've never met him. I don't know where he got my cell phone number from. He is so interested in coding robotics, and he says, please help me. My school has no computers. No one around is me thinking of that. So we will be couriering a game to him today. When he receives it on Wednesday, we'll send him instructional videos and he will start at home. My second last slide. For us, the human issue is very important. On the left-hand side is a group of ladies in Soshanguve who makes our grid mats. They had a little company that went bankrupt during COVID, and we've revived their company, and they've now made us, I think, already 400 grid mats. So they're earning an income. Wade on the right-hand side, and Jackson is my 2IB, the guy that helps me run the show. Wade on the right-hand side packs our puzzles. He had a very serious accident at the age of 14 with brain damage. For the first time in his life, he's now 30, he's earning a regular income, and it's added considerable value to him. I just wanted to know this because these are the heartwarming parts of the project that we really enjoy. And that's our team. We've got 30 coding evangelists all over the country, going into schools, going into communities, working with NGOs, and then giving us feedback. And we're hoping to add another 100 on the 1st of July, all across the country. Thank you. If you want to follow our project, I use LinkedIn the most. I post daily. And then on Facebook, our page's name is Tangible Africa. Thank you very much. It's really been a privilege to sharing with you, and you're welcome to ask me questions now if you want to.
Thank you so much, Prof. Greiling. We really enjoyed your presentation. I just want to ask the people if you can also put your questions on the chat. Otherwise, you can put your hand up, but please also put it on the chat because we want to use it later, all the questions on the chat for research purposes. Can we get some questions?
I'll start answering the questions. The one about contacting DBE as part of the curriculum. I would rather just talk to DBE about making it coding clubs to feed into coding clubs. Schools can obviously choose if they want to use the games as an additional tool in their club. But as I said, we don't have any aspirations of writing textbooks or becoming involved with that kind of endeavor. We'd like to keep it informal and fun. But our main focus is for coding clubs and informal activity, and then informal activity in the class. Assessment, no, we don't want to focus on assessment. We believe as soon as you start assessing, we're taking out some of the fun. I think the fact that our games are increasing levels of complexity from 1 to 35, the assessment is in the gamification, which kids already understand. So without them knowing that they're being assessed, they're improving. So the assessment is, can you do level 5? Can you do level 6? Can you do level 7? And I wish I could show you all the WhatsApps I'm getting from across the country as they assess themselves and learn. That's the great fun.
Thanks, Prof. I think we will definitely have more questions. Can we just get more questions? I just want to ask, Prof. Like you said, it is available. Is it available for free in any of the township schools?
No, well, free is we charge for the puzzles. Our business model up to now has been probably 90% corporate sponsors that we convinced to give us some of their CSI funding, and then we make it available to schools. Schools that buy them from us, a pack of games, codes, tokens is 150 Rand, a kit, and the school only needs one kit. That's 8 games with lessons, solutions, levels, etc. Is 3,000 Rand for foundation phase and 3,000 Rand for senior phase. So we think we are still very much affordable. We can't make everything free. I don't get a salary out of this. I'm HOD. But you need to have some income to make it a sustainable project. That's how I kind of rationalize it. We don't give away everything for free. But I think 150 Rand for a pack of 5 kids can play, or 3,000 Rand for a school. I think it's more affordable than most other interventions.
That is true. That is really true. Do you have more questions? I'll check. I don't see. Yes.
And I just saw Nomusa doing great work in Mpumalanga, Witbank area with our coding and other stuff. So she's one of our bright stars, really making an impact in Mpumalanga with offline coding and breaching the under-resourced schools. So I just want to give credit to Nomusa.
Thanks, Prof. I just want to know, is there any other questions though?
I see Joey is unmuted herself, so maybe she wants to.
It's me that's
oh, is that you? sorry.
There's a question on the chat box,
from Victor. Yeah, obviously all the teachers I train are not in coding robotics because schools don't have coding robotics teachers, so they're from different backgrounds. The one that I know that has been very well accepted by teachers is the maths teachers. One of my facilitator, George Jerume from Milnerton in Cape Town, is at AMISA now. He's got a paper accepted on how he used tanks in his maths tutoring. And then Janine Olivier is in Humansdorp Secondary School. She's working towards registering for a master's on the impact of tanks and coding in a maths class. So the best feedback I've had is regarding maths. My wife is a grade 1 teacher. She says this had a lot to do with all the other skills they have to teach in grade 1. So teachers say that generally, but I haven't really concretely put that on paper, except for maths. There's a lot of anecdotal evidence at this stage. I can't call it research. They call it triggering the mind. When the kids start solving problems, whether it's tanks or just a Pinterest example, the mind is triggered, and they said that kind of triggers the mind to do better in maths. But that's anecdotal observations at this stage.
Prof, there's another one. It says, do you think self-efficacy should be considered as a computational thinking skill?
I'm not sure whether it's a computational thinking skill. The people that are cleverer on these terminologies could answer. But I think it's a critical skill for any learner. And if I understand self-efficacy correct, we often pick it up that teachers say, we're starting to play tags, and suddenly this kid that I never noticed before becomes active, and not only in tanks, but also in the rest of the school. I think Kulumanko is a good example. I once went to train in Wolseley, probably not self-efficacy, but also something that and the headmaster came to me and said, Prof, we're a bunch of gangsters in the school. I'm worried for your training. We played with the kids, and the team that won was the biggest gangsters in school, and they represented the school in a tournament in Wolseley.
That's incredible, Prof, really. I didn't see any other questions. Maybe we will give an option for the last question.
Yeah, I've got to agree with Ian. Obviously, I must agree. devices, it's good to have kids introduced to devices, but the old school, my graduates that are now, well, David Brown in Microsoft, someone that's a big developer in IT in the UK, all say to me, Prof, we started learning coding with our devices. Take away the devices as much as possible. But again, that's anecdotal comments from people, but I think if you're vice president of Microsoft and you're a brilliant developer, I've got to listen to you.
Thank you so much, Prof. We really enjoyed your talk. We will come back to you for some kids, for some of our schools, that we can maybe distribute it to the schools in our areas. I know Polokwane and Soshanguve will definitely also join the club to be part of this whole project of yours. Thank you very much for your time, and we will get back to you soon.
Tanya just asked it. Tanya, if you could please email me, then I can respond. My email address is on the last screen. Yeah, I will definitely like. And if anyone else wants Keith's computational activities, I'll email them to you. But just please email, because if you WhatsApp me, then I'm not at my laptop. When I read your email, I can respond immediately. Okay.
Thank you so much. I think then we will end the session now. We're actually very good on time. And then, Prof. John, we will invite you, if you want to, you can also come into our webinar tomorrow morning, when we will have, again, Prof. Raymond Lister talking to us. So I just want to thank everybody for your participation, the questions, etc. And we look forward to seeing you tomorrow morning at 9 again. If you don't have the links, remember we're on Facebook and we are on the Teams links. If you do not have the links, just contact me or Bertie, send us an email or contact us, then we can send you the links. But Bertie, do you want to add something as last thing?
Yes, please. The people will notice that on the chat I've placed a link for a quick MS Form survey, very short, not a long set of questions. We will be very thankful if you can complete it for us. If you know about colleagues that also joined us, please also complete it. If all the information pertaining to your personalized info is confidential or not required, but we would like to get some feedback for research purposes. So the link is on the chat. So it is available for everybody. We really look forward to the speakers for tomorrow, and also to Professor Lister. I think from his presentation, we really learned a lot, and it will present us with an opportunity to kindle our own curiosity and let us kindle our thoughts with regards to assessment and Bloom's taxonomy. Some very valuable things has been said today. And then also during the past, I've known Prof. Grylem for some time now, but during the past week, we made some wonderful acquaintances and talked about various things. And he has a very big passion, as you can see, for the learners in our country. And from my side, I would say thank you so much, Professor, for sharing all your wonderful knowledge with us in the project that you are involved in. And may we reach many children across our country and in the rest of the world in Africa. So that's all from my side. Ladies and gentlemen, we will really appreciate, just a final reminder, your comments and feedback, but then we look forward to seeing you all again tomorrow. Thank you also to Prof. Joey and to everybody that participated and that assisted us. Also our TUT technical team with multimedia. Thanks, Chris, for assisting us and being available for us. We can really, everybody give a hand of applause, and then we're looking forward to seeing you again tomorrow, and there we're spot on the time. Thank you, ladies and gentlemen.
Thank you, everybody. We greet you now. Bye-bye.